Alright, so we're going to continue on with our project here, Space Invaders. So previously, on the kind of last lesson, the first lesson we kind of built our spaceship and our alien graphic, and then and got those to display. The next lesson we built this game object class that we're using to kind of take care of those operations, so now we can draw them, and we'll implement now the move functions. But before we do, something I want to come back to here with our game object class is that we are still getting warnings, and we made some changes. So the first thing I want to point out is we did change the name here, or I guess down, yeah, here, instead of, I think we had said bitmap, and we're calling it graphic now. And then we were getting an error because the sequence of these was out of order with these. And so we changed that, or it was an error, it was a warning. And actually it was causing some problems. And then we also need to change now the order here to match up there as well. So X position and Y position should come first, and that's why we're getting these little yellow squigglies. They're telling us that something's wrong here. So X position, Y position, width, height, and then we have, the graphic should come next. And then the display after that, and then the speed we don't set, so we'll just leave it here. And we'll see if that works. And then in the meantime, there's something else that we kind of glossed over that I want to bring some attention to. Okay, that solved that issue. And so we had questions about this right here. So this ampersand right there and right here. And so what's going on there is this. This is called a reference. And so what this is a reference to an Adafruit SSD 1306 display object. And so what you can think of is that every time we create a variable, it's got a little space in memory, and every time we pass that variable to a function, we make a copy of it. So for example, when we create this alien ship game object, then there's a space in memory set up for that alien ship, and in that space we have the number 50, the number 10, a 12, and a 10. And then we have, for the alien ship in the display, instead of copying over this entire array, and instead of copying over this whole object, what it does is it just has a reference, which basically says, this is how you find this in memory, so when you need to use it, you can go get it. And you can think of it, for a couple reasons, it's a little more efficient because we don't have to go and make copies of objects that are kind of big. But also, we don't want to make copies of the display object because we just have one display, and we want to have all objects be able to send data to that same display. So if we make a bunch of copies of this in each of our classes, then we'll get some kind of weird behavior, and each of these display objects will have its own buffer, and then things will get kind of weird. We won't be able to draw onto the same thing. And so when we pass this as a reference, when we grab the reference to it here, and we store it as a reference, what that means is now instead of copying it, we just have nowhere to find it in memory. So anytime we want to update the display, we're updating the same display instead of a copy of it. And then in this case, this is kind of like the C++ way of doing it, and this is more of a C thing where we're grabbing a pointer. It's the same thing. The syntax is just a little different here. And so this represents basically, because this is an array, right? The graphic is a list of values. We don't want to copy over that whole list. And so when we pass this object, what it does is basically to say, this is where the first one is, and you can get the rest of them from there. And so we store the location of the first one, and then when we want to access those, we can say, so if we have graphic, and we know this represents the location of the first item in that graphic array, if we put the 0 here, it will actually give us the first item. And then as we change this value, it's going to work its way through that array in memory. It's going to go find those locations and give us those values. Okay? So anyway, this is a efficiency, save memory, and so we don't have to make copies of things that we don't need copies of. Okay? And this is just how it works when you send arrays to function anyways. I don't I mean, I think there's a way that you can make a copy of it, but I think you have to do it within the, yeah, you would have to copy it from within the function anyway. So, okay, so with that said, what we're going to do now is we're going to implement our move functions. And what I'm thinking about is we have one speed. We should probably have two speeds, right? We need one for up and one for down. So we're going to say, we'll call it X speed and Y speed. So, because like the spaceships, for example, are going to move up and down. So for, not the spaceship, the alien ships. And the spaceship won't move up and down, or maybe it can, I don't know, it's up to you. And then, so what we'll do here is in our move vertically function, we want to use the Y speed to control how far it moves each turn. And then here we'll use the X speed. And then we'll make a function, so void set X speed. So this way we can tell it how fast it should be. Nope. And so we'll say X speed equals speed, just like that. We'll do the same thing for the Y one. And this will allow us to update those speeds for different objects, okay? Okay, so this is good. It's gonna, let's verify it, make sure we're all good still, and it compiled successfully. And so let's come back to here now, and we'll use those move functions. And so we've got our alien ship and our spaceship, and so let's set their speeds. So we're gonna say alien ship dot set X speed as 3. And we'll say X, our spaceship dot set Y speed, or X speed, sorry, gotta do both of them. We'll leave that one at 5, and then we'll set their Y speeds as well. So change these to Y. We'll change the Y speed to maybe be like, for the alien, be 1, and the Y speed for the spaceship to be 0, because we don't want to move up and down maybe. Okay, and so now we're going to move them. So alien ship dot move horizontally, and what we'll do is we're going to make a type def here, and enum left, right. Nope, we're not going to need this actually, because we need a different one for up and down and left and right. That's going to just get confusing. So what we'll do is we'll just put in positive or negative. Actually, what we'll do is this instead. We're going to say pound define. I'm going to say left is -1. I'm going to call it move. So move left is -1, move right. And so what these will do is will contain the directions relative to display. So move up will be -1, because we're referencing from the top. And move down will be 1. Okay, and so now when we tell it to move, instead of putting a number, we're going to say move left, and then spaceship dot move horizontally. We'll tell it to move right, And then one thing we have to think about is how to bound these movements. And so what we can do is this. Okay, at this point, actually, before we do anything else, we want to test it. And I started this testing, and you can see that my alien spaceship is moving across. But you can see that my regular spaceship here just stays right there. And what I notice is I have this spaceship moving vertically when it obviously, we set that speed to 0, so it can't move vertically. Something else that you'll notice is interesting is you'll see that this alien spaceship is wrapping around. And so the reason why is that we're using the data type that we're using to track the position is an 8-bit integer, which only can go to 255 from 0 to unsigned 8-bit integer, so it can go from 0 to 255. And so when we go to 0, when we subtract 1, instead of going to -1, it goes to 255. And that's why it's kind of wrapping around like that. But what we want to do here is let's change this to move horizontally. And then we can also make our alien ship move down, maybe, just so we can see it happen. All right, and then we can test that. But so what we have to look at next, though, is how we want to bound these things, because we don't necessarily want it to keep wrapping around forever. And so we have to think about how we want to stop it, like if it gets to the edge, and how we would detect that. And so one of the things we want to think about is how the positions are set on the screen. So it starts at 0, 0, and now is our aliens one's not right. Why is there an alien? Oh, okay. Another typo here. So this should be vertically. Sorry, we make mistakes sometimes, you know? Especially if we're talking while we're typing. Okay, so this should be move vertically. It would be nice if we did like an enum here, so we could like get errors when we put the wrong direction in. But something to think about later. Okay. So now we see them working. There's our spaceship going across the screen, and at some point our alien will come back. We'll start over, there it goes. So it dances its way off the screen like that. Okay, so we want to set some bounds here so that if we're already at the max position, that it doesn't go off the screen. And so one thing we could take a look at is what we can do with this display object here. I'm wondering, so if you can see, if we control click on it, it brings up the definition of it, and these are all kind of the different constructors, so different ways that we can make it, and then all the things we can do with it. And I was thinking we might be able to get a I was thinking we might be able to get the bounds of the display, like the horizontal and vertical positions of it, but it doesn't look like it, like the number of pixels. If we go to, let's see, so this is the class, and then it's a it inherits from this class. We won't really get into that right now, but it's got functions from this class too. And it doesn't look like we can grab it here either. Okay, that's fine. I was thinking if we could get that information from these, then we could have it be fixed as part of that. What we'll do instead is say undefine. We'll call this display width, which is 128, and display height, which is 64. And so what we want to do is we're going to use these variables, or these includes rather, to set the bounds. Oh, we have already there already. We're just going to move them over here. So we're going to cut these and we're going to put it in here, and so we can use them in our game object class. So when we move, if y position let's think about this. If y position is greater than or is less than say u int 8, let's call it int direction, int move size equals direction times y speed. So we're going to calculate the move size, and if y position is less than how do I want to do this? Let me think for a second, I'll come back. Okay, what we're going to have to do is this. So we're going to have to change these positions to not be unsigned int. So we're just going to call these ints. So it's a bigger data type. I believe this would be a 16-bit int. Actually, we'll just make it a 16-bit int. And so now, because what we want to do is we want to be able to see when it's negative. So we're going to say int new y position equals y position plus the move size. So that will change. And so if this is less than 0, then we're going to set the y position to 0. Else if new y position is greater than or equal to the screen width. So because it's 128 pixels, but we start with pixel 0, and so that will this will prevent it from hitting that, going off the screen there. Now we have a problem here still that we'll talk about later, because this will still render them off the screen, but we'll fix that next. And then we'll set this to be, so y position equals screen width minus 1, or else y position equals 0. No, equals, sorry, new y position. Okay. And now we're going to say if y position, we're going to change this to be return a boolean, a true or a false, and we'll say returns true if at boundary. So if the y position is equal to 0, or the y position is equal to screen, this should be height. Screen height minus 1. Put these in parentheses here. It's not needed, but it helps to read it. Then we're going to say y position, or return true that we're at a boundary, else we're going to return false. And this is something we can use to know when we're drawing it if it hit the boundary. Okay. And so we've got move vertically. And so what I would like for you to do is to take what we did here with move vertically and do the same thing here with move horizontally with the x position and the screen width. Okay, and we haven't tested this yet, so once we get those written, we'll test them. We'll see how they do, and then we'll kind of take the next step from there.